Okay, you're on.
Okay, so what I'm going to show, and I realized just now in the last few seconds it may be challenging, but we'll have fun, is to demonstrate to you some teaching tools that we're developing at Yerkes Observatory for teachers to use electronics, intelligent electronics in the classroom. So basically, something like the thing you built 1 hour ago with Kevin. How do I make that intelligent? Add a little display to it, and add it to, say, an exhibition or something, or just make it a lab such that the students can just sit down and then read a little screen. Or do anybody's students actually read instructions?
No.
No, they don't. Okay, good. Well, the few that do that, we can actually have them run the thing by themselves instead of having to run after each and every student. Okay, so a few things about myself. My name is Marc Berthoud. I'm an instrument scientist for GHOU. I work up on top of the hill, and my day job is to help build, test, and do programming for the GHOU instrument that is one of the cameras that's going to fly on SOFIA, NASA's airborne telescope. So I'm just to outreach kind of to the side thing when my boss is not watching. Carl, don't tell Jim. Thank you. And so basically, whenever I get to it, plus with the help of Vivian, we found a lot of amazing interns that are working here at Yerkes. And most of what I'm going to show here are stuff that these interns have been doing and are actively working on. The thing I'm going to talk about is the Arduino, and so Arduino is a microprocessor, and why don't I just hand this around? Now, does anybody have a flashlight?
A flashlight? Mm-hmm.
So this is a light sensor, and you can hear it. You can hear different frequencies, higher frequency, more light, lower frequency, less light. If you just want to play around with it and not be annoyed by the sound, there's a little switch here. You can flip it over, the microphone goes off. Okay? So I'm just going to pass that around and, take a look at it, play with it. So that's an example of what you have there is an Arduino microprocessor. That's the thing at the bottom. And it's basically a small board with a microprocessor and a variety of input-output ports. Now, the main thing is the USB connection, and that allows you to simply upload programs to the Arduino like this, or also to upload data from it to the Arduino. The Arduino also has multiple digital and analog input and output chips. Actually, one of these analog inputs is working right here on that Arduino right now to measure light and to digitize the output from the light sensor. It's a simple C-based programming language with which you program the Arduino. However, in our project, we don't require teachers to learn C. We have prepackaged programs they just put on the Arduino and then go with it. Now, the interesting thing about the Arduino, and which is why I like it, especially for teachers and for schools, is that it's an open source design. The design of the Arduino is open source, and so is all the software that you use for it. That means anybody is allowed to take the design and produce their own boards like this and sell them for profit. So basically that means there's an incredible amount of innovation and competition in these devices, which is nice for us because it keeps for us consumers because it keeps the price low. The other thing is that the Arduino has a wide user base of hobbyists and educators. There is a teacher out there that's in the process of writing an electronics teaching course with Arduino. There are other teachers that are working on building applications for the classroom with the Arduino. So this is not just something we're building here. There are a lot of different people that are using this platform and building on it.
You can talk more about the board or tracks or something?
Yes, go ahead.
So it has some own flash memory on board?
Yes, it has own flash memory, volatile, non-volatile. Basically, the thing is, if you can take that one out there, you unplug the battery, you plug it back in, it just starts the same program that it was running before. So you can unplug it from your computer, plug in the battery, and it just keeps going what it was doing before. And the other nice thing is you can record data on the non-volatile flash. So basically, you attach a temperature sensor to it, give it a program for it to record data, light in the backyard, or you put it on top of your roof and have it record the light level for 24 hours a week, whatever. Plug it in, you load another program to it to read the stored data onto your computer, and you have a remote logger.
What's the architecture of the chip like?
The architecture of the chip is it's the same. It's basically a normal CPU, 12 megahertz, something on the order of a 8086 or 186.
486, okay.
So something like that.
Probably not a lot of the Microsoft instruction sets like that that they threw away.
Yeah, they probably. Well, the thing is actually this chip or a compatible design is used in a lot of applications like cars. The average car has 5 similar chips, each not the same chip in it that just do various things. Little intelligent parts of your car, for instance.
Wow.
Yeah. So that's it's being widely used. Not this board, just the main microchip that you see here. Okay, so other things that you do with the Arduino, as you see here on the upper right, it's quite easy to just put something together. And this is just use a breadboard, use a sensor, or light switch, anything, and just at the top you see the USB cable that comes in, which also powers the Arduino if you connect it to the computer like that, and then you can just connect your electronics to it. Another thing you can do that you see on the lower left is there are these shields that you can plug on the Arduino. This is, for instance, one that allows you to print text. You can also use several shields on top of each other, and then for instance, there are shields for running electric motors, running servos, for having a color display, lots of different things. Actually, let me give you guys a few demonstrations here, what other people have done with this thing. That is interesting. Very unfortunate if I would need to reload this. Okay, so this is somebody used the variable output of the Arduino to...
There's sound?
No.
Okay.
To just increase and decrease the light of 3 LEDs. There's a red, a green, and a blue LED in there. And using the Arduino and the analog outputs that can output anything between 0 and 5 volts, you just increase and decrease the color, and you have your cube shine in different colors. Another example... Another example that somebody did, there are Arduinos that because it's an open design, people have come up with all kinds of form factors and with different kinds of breadboards. And this is a sample of an Arduino. Somebody using conductive wire. That person has sewn that Arduino in the entire circuit in the sleeve, and has now a digital clock in that sleeve. Unfortunately, I didn't see that. There was a very nice one of a person that had lights across the front of a T-shirt, and they were blinking up at different intervals, just at a given pace. Or you can add a little light sensor, and then depending on what the background light is, or an accelerometer, depending on how the person is moving, then the shirt lights up in different colors. Another, of course, a big application is anything that moves, and that's also something we plan to build at Yerkes, a small demonstration of an old as mount that people can then program by themselves. Let's go a little bit earlier. Can then program by themselves. Now this is somebody made a little robot, and this robot is very simple. It's basically just a breadboard, some resistors, and it has 2 little antennae in the front. Whenever they get pressed, then the little robot starts to notice that there's something going on, goes in different directions. your sound would be good because the robot is not that fast and they have cool music. So watch this on YouTube. Actually, good. Never mind. Yes. So yeah. So basically, that's something. Example of things that people did with this Arduino. Why do we want to use the Arduino for education? What do we want to do? Basically, the goal of our study test is to produce simple, cheap, reliable measuring and recording tools for science lab education. The thing on the right is one of the typical devices that you can buy for the classroom. The basic recording device is about $150, plus each sensor is an additional about $20 to $25. We're about 5 times cheaper with the Arduino. What we plan to provide is designs that work for the teachers that they can use, activity instructions and lesson plans. So this is something that we hope to work with some of the Yerkes teachers to see if somebody wants to try that in the classroom and see how that works. Hopefully we can find some kids that we can try it at Yerkes, maybe. And also that may provide a variety of sensors and hardware that the teachers can use. Demonstration. Okay, so I already demonstrated to you the, now I'm going to be very much out of space here, unless I close a few things. Yeah, was there? Yes, there was this here. Let's see. Let's first see. Now the thing is, this program is still in the development stages, so basically I have to look at how is the Arduino tells the computer that it's a USB modem, or the computer recognizes the Arduino as a USB modem. I'm not exactly sure what's happening here. But the bottom line is, I need to tell the program manually where to find the Arduino. Once we have that, and this is something, now, anybody would immediately recognize that this is not something you want teachers to do, right? So this is something we're working on a way to make that automatic, that the program automatically find the address of the Arduino. And now, let's see if that works. It doesn't blow up. Couldn't open port block. Good. Oh, FA, not FD. Yeah. Well, demonstration effect. Whenever you demonstrate something, it doesn't work. Oh my goodness, maybe it does. Okay, so basically here I have another Arduino, and it's basically the same Arduino. Now, the Arduino that I passed around, we built the light sensor into a shield that you plug onto the Arduino, and so it makes it easy for the teacher just to take the shield with the appropriate sensor, plug it in, it runs. Here, we're not at the stage yet in this development that we have a shield. We just have the light sensor on the breadboard, and so if we do this, the distance sensor. Now, if I can, okay. Actually, if I had somebody who could go very far away, just stay in the beam. Okay, go further. Yeah. Okay. Yeah. Okay, and now come closer. Yeah, I guess. Yeah, you see that it's a challenge to be in the beam. Yep. Computer's full. Okay. Yeah. Okay. So basically, that's a light sensor, and the hope is that people can do experiments like this eventually, and then and now I can measure the distance of the ceiling. Yes. Now, the other thing you can do here is you can with this program, and this is something that our students